In this video, we'll look at Windows Azure Storage, one of the foundational layers of the Azure technology stack. I will give an overview of the features that it provides, as well as talk a bit about some of the things it does under the hood to keep your data safe and provide high-performance access to that data. I will also demonstrate how to create and manage data in Azure Storage through the Azure portal via graphical tools, and we'll even look at a small script that shows programmatic access to the data. The Windows Azure Storage services provide storage for binary and text data, messages, and structured data in Windows Azure. They're scalable, meaning that you can store very large amounts of data in it. Also, the underlying system will allocate more resources as necessary to maintain a good level of performance when many things are trying to read it at once. Windows Storage is also durable, meaning that the things you store in it will remain there and remain safe from corruption. Azure Storage is also available, meaning that it is always available to your application. This is possible because of software and hardware resiliency engineered into the Azure infrastructure. Microsoft monitors the service, provides patches, handles scaling, and does the other work needed to keep the service available at all times. The cost of storage is also key. You only pay for the storage and transfer bandwidth that you actually use. The data in Azure Storage is available via a REST interface, so virtually all programming languages can access it. An Azure Storage account has a globally unique account name. Each storage account gives your application access to Windows Azure Blob, Table, and Queue services located in a particular geographic region. You need to have a storage account in order to use Windows Azure Storage. Fundamentally, the storage account represents the highest level of the namespace for accessing storage services. You can explicitly geolocate an Azure Storage account to a geographic region or set geographic affinity with other services so that the storage is in the same data center as the compute services you will be using. Each storage account can have 200 terabytes of data across all the different storage types: blobs, tables, and queues. A Windows Azure subscription contains multiple storage accounts. You can create up to 5 accounts for a single Windows Azure subscription. The Azure Content Delivery Network, or CDN, offers developers a global solution for delivering high bandwidth content. It caches blobs and static content at physical nodes in the United States, Europe, Asia, Australia, and South America. Another interesting feature of storage accounts is that they each have 2 512-bit keys, both of which are active. There are 2 access keys to enable you to maintain connections to the storage account using one access key while you regenerate and replace the other access key. Generally speaking, you should update your keys frequently to ensure security. A core feature of Azure Storage is that data is geo-replicated. Every single byte of data that you write into an Azure data center will, by default, be automatically replicated to a second data center that is at least 400 miles away. You can disable this geo-replication if you really don't care to have this level of data redundancy. Turning it off does reduce the cost of storage by a small amount. Azure's management portal also includes great analytical tools for your storage account and the objects stored within it. It provides much more granularity and insight than, for example, a hard drive within your computer. This gives you a different and useful kind of insight into the performance of your applications. Azure Storage also provides a facility to do background copying of large data in an asynchronous fashion. This can be very useful when you need to move large amounts of data around. All the data you store into Windows Azure can also be accessed securely over HTTPS. There are more sophisticated mechanisms for signing and providing more granular security over your pieces of data. So far, I've used terms like blob and tables and queues. These are the fundamental storage abstractions of Windows Azure Storage. Let's talk about them in more detail. All the data stored in Azure Storage uses one of these storage services. The blob service can store arbitrary binary and text data using a key value system. The table service provides a structured, tabular, key value storage mechanism for non-relational data. The queue service is a reliable messaging facility for applications and components to communicate with each other. Programmatic access to these services is available via the Windows Azure Managed Library as well as the Azure REST API. We'll look at blobs and tables in much more detail in a subsequent video. Internally, Azure Storage is a very complex system that has been carefully engineered to provide resiliency and performance for a huge number of customers. While we don't have time to go into great depth about these innards in this video, there are many great videos on Channel 9 that drill into the internals of how this is all achieved. In this slide, we'll just take an overview look at the internals. When a request enters the Azure Storage system, it gets handed off to a layer of front-end boxes. These front ends load balance to a number of partition servers. Each partition server handles a set of object partitions, whether those objects are blobs, tables, or queues, and the partition server layer communicates with a partition master system to load balance. The lowest layer of the storage architecture is a distributed file system, which stores and replicates the data across many servers and hard drives. An important part to know about this architecture is that the partition master not only watches for failure and gracefully handles those, but it also spreads the load from partition servers that are experiencing too much traffic. Let's walk through the simple process of creating a storage account and using Azure Storage Explorer to look at its contents.
First, we'll download Azure Storage Explorer from Codeplex by going to azurestorageexplorer.codeplex.com. You can see here that Storage Explorer 5 Preview 1 is the latest version, but it's a preview. The latest stable version is version 4 Beta 1. In order to follow along with the examples in this video, you'll need to get at least version 4. So we'll just click Download here for the most recent version. We'll click Save. Once it's done downloading, go ahead and run through the installer. Now before we can actually use the Azure Storage Explorer, we need to find out our storage account name and the access key. Here, I've created a storage account, and once I click on it, I can select Manage Access Keys at the bottom. This brings up a dialog with the primary and secondary access key. I've blurred them out in the video for security reasons. Remember, there are 2 storage keys for each account, so we can regenerate one of them while the other is still active and used by applications and VMs. This ensures zero downtime while still allowing us to practice good security procedures and regularly generating new keys. Now we launch the Storage Explorer. We click Add Account at the top, and we enter our storage account name. Our storage account key I've copied from the Azure Management Portal dialog, and I'll just paste it here. We'll select Use HTTPS and Add Storage Account. Great! Now we see the storage account in the Storage Explorer. By default, Storage Explorer shows the blob stored in the account. We can change the storage type with the buttons at the right. Let's go ahead and create a new container. We'll leave this public so that anyone with the URL can access the data. As you can see, our container has nothing in it. Let's go ahead and upload a couple of files. These are from the Azure Training Course Examples directory. Once they've been uploaded, we can actually take a look at them. Sample.txt is a plain text file. So when we look at it, not only can we see the properties of the blob and the metadata, we can view it as text, and these are the contents. Cut Diamonds is a CSV file, and we can see the raw text of it here, but it's quite large. Now we'll shift gears a bit, and we'll use Python to programmatically retrieve the contents of a blob, in particular the Cut Diamond CSV blob, and then we'll create entries in a new table for every single row in the CSV.
This shows some Python code that uses the open source Azure Python SDK. The first line connects to the blob service and returns a connection object. Then, by calling createContainer on that blob service object, we create a new blob container in our storage account. The first line here reads the contents of a file named task1.txt. The second line then calls the putBlob function to upload the data to the blob service. This slide shows the code to read a list of blobs from a given container. The code is very simple and straightforward. In this video, I introduced the core concepts of Azure Storage, and we walked through creating a storage account with the Azure Management Portal. Hopefully, you have seen that Azure Storage is very simple to use, from either graphical tools as well as a programming API. However, using it properly requires more knowledge about the details of the different types of Azure Storage. Please watch our follow-up video about Azure Storage, Blobs and Tables for more information. Thanks for watching.